Hello, scholars. We're going to be reviewing some ideas for the summative coming up on Friday. And I think just the best way for us to make sure that we're comfortable with the ideas is I talk through some of the problems on the worksheet. Of course, you could see the solutions listed in the answer key, but sometimes it just helps to see somebody work through them. And so our learning target is really a review learning target. That's what we're going to be doing. We've been graphing linear equations, we've been writing linear equations and using several different methods, and then we've been solving systems of equations with 2 and 3 variables. That's what you will be able to do when you get done watching this video, is continue to review on your own how to do each of these ideas. So what I'm suggesting is that we're just going to take some problems off of the review sheet and I'll work through them and kind of talk them over. When we have a pair of equations like that, we call it a system. And in this case, there are 2 variables, x and y, and what we end up with is an ordered pair that describes where the 2 equations usually intersect. And so I'm just going to start with this first equation. I notice right away y equals negative x plus 4. This one right here is in y equals mxb form. So I'm going to take this number and I'm going to put it 1, 2, 3, 4 right there on that y-axis. Then I notice that the slope, or the value of m, is negative 1 and b was 4. So what that means is it's the rise over the run, or how far you go up and down over how far you go across. So I go down 1 and over 1, down 1 and over 1, down 1 and over 1. That is the line that is described by y equals negative x plus 4. Now, what we want to do with that is we want to graph the other equation and see if we can figure out where they intersect. So I'm going to just do that over on this side, and I have this x minus 2y equals 10. And what I'd like to do is subtract x from both sides. When I do that, I end up with negative 2y equals 10 minus x. I need to get rid of the 2 in front of the y, that coefficient, so I'm going to divide by negative 2 on both sides. What that leaves me with is y equals 10 divided by negative 2 is negative 5, and negative x divided by negative 2 is a plus 1/2 x, or just 1x over 2. So what I want to do is I want to take that and graph it. So I notice that the slope is 1/2, positive 1/2, and the y-intercept is a negative 5. So I'll go down to negative 5, it's 1, 2, 3, 4, 5, and I'll go up 1 and over 2, up 1 and over 2. Those are a number of points that intersect, and then I draw the line and try to get it as best I can. I'm a little off of this point down here, but what we're doing is just trying to estimate. And so what I think is the case is that right here, let's just say it's a nice big point. I go 1, 2, 3, 4, 5, 6 over and down 2. So I think that is the solution to the system of equations. And it's approximately 6, negative 2. What we would say that about those 2 equations, just in terms of these descriptive terms, is they are independent. They're 2 different equations, and then they intersect, so they're consistent. So we say that they are independent and consistent. So I'd like you to try the other problem number 2 on your own. And I started this problem for us just because I want to shorten up the videos a little bit. And what I noticed right here is wherever I saw a y equals negative 8 plus 4x, in this equation up here, all I did was plug in that negative 8 plus 4x. And what happens then is I get x minus negative 1/4 times negative 8 is a positive 8/4, which is the same as 2. And so I'm going to change that to a plus 2. And then negative 1/4 times 4x is a minus 4 over 4x, or just x. That equals 4. Now, what I notice is when I combine like terms, my x's take each other out, and I'm left with 2 equals 4. What should be going off in your mind now is that is not true. That is actually false. 2 is not equal to 4, which means this is a no solution. Which, if we were to graph this, I think the two equations would look something like this, where they're parallel to each other. They don't ever intersect. So they are independent, but there's no solution, so it's inconsistent. They don't ever intersect. Wanted to do one more like that. And so right here, all I did was subtract x from both sides, and I ended up with this equation right here, 3 minus x. And that's what I'm going to put in right there. So, which is the top equation, 3 times this quantity minus 11y equals 16. So all I did is took this equation, wrote it here, and where I saw an x, and by the way, I see that I made a mistake already. Sorry about that, because I would not put it there. What I would do is I would put 3 minus x in for the y, and I put it in for the x. So sorry about that. It's 3x minus 11 times 3 minus x equals 16. So then we end up with 3x minus 33 plus 11x equals 16. When I combine like terms, it looks like I'll end up with 14x minus 33 equals 16. So what I want to do is I want to add this to both sides, and I end up with 14x equals 49. So we're in a good place here. So what I want to do is divide by 14, and it looks like this will cancel out, and x will equal 7 goes into 49 7 times and into 14 twice. So it looks like the value for x is 7/2. So what I want to do with that is put that back into one of the equations so that I can solve for y. And so I'm going to choose this one right here. I know that y equals 3 minus, and the x is 7/2. Now, here's where it gets a little difficult. This is really 3 over 1. And what I would suggest is changing it to common denominators. 3 over 1 is the same as 6 over 2. And if I subtract 7 over 2 from 6 over 2, I end up equaling negative 1/2. And so my ordered pair is 3 1/2, which is 7/2. In fact, let me just write it that way so you don't get confused. My ordered pair, the solution is 7/2, negative 1/2. And since I don't have room, I'm going to check it down here, and I just know that, yes, it does work. What we end up finding out is that these are consistent. They intersect in this point right here, and these two equations are independent. They are not on top of each other, and they are, of course, not parallel. This next one, number 7, I'm just going to get you started on. And I really already started it a little bit because I'm going to call them A, B, and C, and I'm going to try AB over here. And between these two right here, what I notice is it's really nice when I just add straight down, the Z's cancel out really beautifully. So what I'm going to do is write the x minus y minus z equals a negative 4 right there. And then I add 3x minus 4y. These cancel out, equal negative 2. I'm going to hold this for a second and go to my second set of equations. What I notice is this would be really nice right here if that were a positive z, because when I add it with a negative z, they cancel out. So I'm going to multiply this equation by a negative 1. And when I do that, I end up with this. Just what I wanted. Now when I add the columns, I end up with negative 4x plus 3y. These cancel out, equals 5. And what I want to do is bring that over here. And I am going to let you take it from there. What I would suggest is nothing cancels out really easy. So if you multiply this one by 4, we're going to get 12x there. And then we want this one by 3. So the equations are going to look like this. I did that wrong. Let me correct it. Be minus 12x plus 9y equals 15. You take it from there, solve. I think what you will end up finding is a negative 2, negative 1, and 3. It's going to set this one up for you, and then I'll let you take it over, because sometimes I think it's the setup of these word problems, these that just kind of get you and get you frustrated. So what I always look at is, what are we trying to solve? How much does each type of flower cost? So I just set something up for you. I defined each of the variables. X is the cost of daisies, Y is the cost of the roses, and Z is the cost of the daffodils. And now I'm just going to take each problem one at a time and try to write an equation. It says 5 daisies. So the cost of 5 daisies is 5 times X. Let me get a better color here. The cost of 5 daisies, 1 rose and 1 daffodil, is $40. There's my first equation. The second equation I'm going to look at is here. And what I want to do is just say, okay, buying 1 daisy is X, and 7 roses, so plus 7y, costs 44 more than 4 daffodils. So the equivalent, the equal, or the equation that we want to write is 4 of those daffodils. But what we have to do is figure out, where does that 44 go? It says buying 1 daisy and 7 roses costs $44 more than 4 daffodils. So if I add $44 over here, they're going to be equivalent. Now, the other thing I could do is just subtract 44 from X plus 7y, then they would be equal. If I did that, and I'm going to suggest that you do that, I back up. I'm going to let you manipulate this equation to get it the way that you want. And then the last thing that we'll look at is this statement right here. It says 3 roses, so 3y, three roses that's the cost of 3 roses, cost $16 more than one daisy, and a daisy is X, and one daffodil, and the daffodil is Z. So what we have to do is figure out, okay, what 3 roses cost $16 more. There's more dollars on this side, so if I add 16 over here, there I end up with my 3 equations. I'm going to let you take it from there and choose, what's A, B, and C. Choose what you want to eliminate, and what you should find is that I think that the daisies are $5, the roses are $9, and the daffodils are a measly $6. So that's our X, Y, and Z. I thought I'd get this one started for you. A food truck sells salads for $6.50 and drinks are $2. The food truck's revenue from selling a total of 209 salads and drinks in one day is $8.36. How many salads and drinks were sold? Remember, that's what you kind of want to start out thinking about. Is this, how many salads and drinks? And so that's why I said the number of salads sold is S. The number of drinks sold is D. So we know that there are a total of 209 salads sold in one day. So that's my first equation right there. The number of salads plus the number of drinks is 209. And then in that same day, the revenue from the truck was $8.36. I know that. So what I have to do is find out the money that came in by salads. So it's $6.50. So I want to take $6.50 times the number of salads. That's this term right here. Then I want to take $2 times the number of drinks sold. That's the money that comes in from beverages. So if I add salads plus beverages equals $8.36.50, I'm going to let you take it from there and do it however you want. You'll notice up here that I suggested that when I was looking at the problem, I thought, well, maybe it's easiest to just substitute. Get S by itself, plug it back in, and you see what the costs of each of them are. Or not the cost, but the number of salads sold, the number of drinks. In this number 11, just really quickly, should be one that would take you less than a minute. You know that the slope is -1/2. You know that this point here, 0, -2, is a point that line goes through. So right away you go, there's no way that this line can intersect anywhere up here or down here or anywhere in between. That has to be the y-intercept. So all you have to do is write that equation. Just want to remind you that when you have a line that is perpendicular to something, what you do is you start solving this equation like I did here. You find out what that equation looks like in slope-intercept form, and then you say, okay, the slope of this line is -4/3, which means any line that's perpendicular to it is the negative reciprocal. And so that's why I said the line perpendicular to the original has to have a slope of 3/4. I'll let you take it from there and just confirm that what I did here is correct. And then I'd like you to finish that problem. Actually, I see that I did it right there. In number 15, and this will be one of the last ones that we do, what I want to remind you about is that when you are given 2 points and neither of them are really an x-intercept or y-intercept, I think the easiest thing to do is remember that slope is the change in y over the change in x, or the rise over the run. So you can use this equation. You notice that I did it right over here. I ended up getting this number as the slope. And so negative 1/3 is the slope. What I did is I kind of went from there up to here and said, okay, I'm going to put negative 1/3 in for m. And then I'm going to choose, I just chose this point because this one over here had a negative in it, and the 29 kind of makes me think that it could get kind of a bad fraction. So I chose the one that looked a little cleaner, and I put in 15 and 20 for x and y, solved it, and I ended up finding that b was equal to 25, which means then that I just needed to really finish this off and put the y-intercept of 25 into the equation, and the slope that we found, negative 1/3, went in there. So this was what I ended up with as an equation for number 15. So with that, you could do a very similar problem down here, except now remember this is called slope-intercept. That's supposed to be a C there. What you want to do in this one is the same process, but make sure that you put it in standard form, just so that you know the difference. So thanks for listening. What we've been talking about is just reviewing the various things that we've covered so far this year. It's been writing equations of lines, graphing equations of lines, finding their intersecting points, using algebra to solve systems of equations with 2 and 3 variables. That's what we've been talking about. Hopefully this was helpful. You have more to do because I only did a handful of them. Thanks for listening.